Just-in-time interpreters are what languages like Java and Python use to turn your code from the words you write into the ones and zeros that your CPU can understand and execute your instructions on. So it starts with lexical analysis, which is basically it's going to go through and identify every single word or variable. It's like saying like x is a variable, int is a type, equals is an operand. It's like going through a sentence and saying this word's a noun, this word's an adjective, this word's a verb. Next, you have syntax analysis, which creates abstract syntax trees. It's a big word, really just means it's going to look at the sentence and say, like, does this make grammatical sense? It's going to look at the sentence or the line of code and it's going to say, does this make sense? It's also going to map how everything interconnects across all the files, all the functions, all the objects, classes, interfaces. It's going to see all the interconnections. Now, what's really interesting about JIT interpreters, just-in-time interpreters, is that they're going to convert your code into bytecode. And the reason for this is, well, Java was the first one, I think, to do this, where it basically, before this, used to have compiled languages, which would be very specific to the hardware. So it would be, if you compiled the language on a MacBook, it would not work on a Windows laptop. And then Java came out and it started compiling things into bytecode, which was like just like an intermediary. It's almost like assembly, but not exactly. It looks very similar at times, or it's very readable in the same way. But at that point, then when you would execute that code on any computer hardware, it would then compile from that bytecode in the virtual machine. So the JVM for Java or the PVM for Python, it's like Python virtual machine, Java virtual machine. It would convert that into the language or the assembly instructions, or like it would convert that into the assembly instructions that CPU is made for. So it would be like x86 is gonna be CISC, or ARM and M1 chips might be RISC based instruction sets. And then those instructions, once those assembly instructions were made, it would then turn that into ones and zeros. Java would go one step further, and once it made that in like the assembly instructions based on that CPU, it would also monitor what part of your code base runs the most often, and then it would go back like compile languages and actually optimize that in like sections, making it just as fast as C and C++ in some areas of your code base. But basically, it's like an interpreter where it does lexical analysis and syntax analysis, or like a compiler. But instead of doing semantic analysis, where it like makes sure that all your code works according to those restrictions, and doing code optimization, instead it has a virtual machine that stores all the information like in memory, and you have to clean it out yourself, or it has a garbage collector cleaning it out, and then it executes that. And that's all there is to JIT interpreters.